Alright, this video is on Chapter 5, Number 6. A livestock company reports that the mean weight of a group of young steers is 1,148 pounds, with a standard deviation of 50 pounds. Based on the model given below, what is the percent of steers that weigh A, over 1,200 pounds, B, under 1,300 pounds, and C, between 1,150 and 1,250 pounds? So, the main thing here in this question is that we're following this normal model. And so this notation, n parenthesis 1148, comma 50, tells you that my distribution is a normal distribution, so that's what the n stands for. The first number here, the 1148, is my mean. And the second number here, the 50, is my standard deviation. So the first thing that I see when I see a problem like this, I think I should draw a normal curve. So that's what we're going to do to get started. Okay, I've started by drawing my normal curve, or my bell-shaped curve seen below. And so on this curve, I'm going to have it labeled from plus or minus 3 standard deviations out. So I'm going to go ahead and write down what I have here. So my mean is 1,148, so that goes in the center of my curve here. My standard deviation is 50, so I'm going to add 50 to the 1,148, and this becomes 1,198 for one standard deviation above. I'm going to add another 50 to it, so this becomes 1,248 for 2 standard deviations above. And then plus 50 again becomes 1,298 for 3 standard deviations above. And then I'm going to do the same thing over here. I'm going to subtract 50 to be 1,098 for 1 standard deviation below, and subtract 50 again is 1,048 for 2 standard deviations below, and then subtract 50 for 998 for 3 standard deviations below. So I have my normal shape curve all outlined with the mean and plus or minus 3 standard deviations. So the next thing I'm going to do is I'm going to put where the 1,200 is approximately on this. So the 1,200 is right here, slightly over 1 standard deviation. So I'm going to draw a line straight down at 1,200. So this is approximately 1,200 right here. And since I want it to be over 1,200 pounds, I'm going to shade everything to the right of this line. And so basically what I'm finding is the area underneath this curve is going to be equal to the percentage of steers that weigh over 1,200 pounds. So to do this, what I need to do, if I'm doing this by hand, is I'm going to use the normal z-score table that's in the back of our book. So let me show you what that table looks like before we go further. Okay, this is what the table, the normal table looks like. And in this textbook, every textbook's different, but in this textbook, we have the scores are representing areas to the left of the line. So if I have my normal curve right here, let me just sketch this one here real quick here. So if this is my normal curve, and let's say that this z-score of 1 right here, so this is 0, and let's say this z-score of 1, then this area right here, which is 0.8413, is equivalent to the area underneath the curve. But what that's representing is that's representing the area to the left of the z-score. So all of this area that's shaded here is the 0.8413. So we have to keep that in mind when we're using this table, that these numbers on this body of this table is representing the area to the left of the z-score, or to the left of the data value that you have in your normal curve that you have drawn. Okay, we're going to go back to our problem where we're trying to find the percentage of steers that weigh over 1,200 pounds. And so we're back to our normal curve with our shading to the right of 1,200. And so what I need to do is I need to convert this 1,200 here to a z-score so that I can use the table. So my formula for my z-score is the z-score is equal to the data value minus the mean divided by the standard deviation. I'm using SD for standard deviation. So my data value here is 1200. My mean was 1148, and I'm going to divide that by 50. And so when I do that, I get 1.04. That is my z-score. And so really, if you look right here, that makes sense because I'm slightly over 1 standard deviation. So this is equivalent to 1.04. So this is what I need to look up at my table. Okay, so I'm back to the table, and I'm going to find 1.04 for my z-score. So on the left-hand side here, I'm finding 1.0, and then on the right, up on the top here, I'm going to find 0.04, and I'm going to follow these across if I can. So I'm following this row here across, and I'm following this row down, and where they intersect here is the area underneath my curve. So I find 0.8508. So that will be the area to the left of my z-score line. So the 0.8508 that I found in my table actually represents, and I'll shade this area in blue here, the 0.8508 actually represents this area underneath the curve, all of this area right here. So if that is 0.8508, then the total area underneath the curve is 100%. So I need to basically take 1, which is equivalent to 100%, and to find my green shaded area, I'm going to take 1, and I'm going to subtract 0.8508, and I get 14.92. And so, actually I get 0.1492, sorry. So let's change this to 0.1492. I'm getting ahead of myself. And so I'm going to change this to a percentage, which is 14.92%. So the area to the right, which is the green shaded area, is 14.92%, which means that the percentage of steers that weigh over 1,200 pounds is 14.92%. All right, this is part B of the question. So I want to find the percentage of steers that are under 1,300 pounds. So I have drawn my normal curve again, and I have labeled the axes down here with my mean and plus or minus 50 out to plus or minus 3 standard deviations. So again, 1148 plus 50 is 1198, 1198 plus 50 is 1248, etc. So I already have that done. And so I want to go under 1,300 pounds. So 1,300 pounds, sorry, is about right here. So I'm just going to draw a line straight down to 1,300 pounds. And again, I'm going to shade the area underneath the curve that represents us. So since I'm going under 1,300 pounds, that's the area to the left. So I'm going to shade all of this. And that's what I'm finding. So again, I'm going to convert this to a z-score. So my data value, which is 1,300, minus my mean, which is 1148, and divide it by my standard deviation, 50. And so if I take 1,300 minus 1148 divided by 50, my z-score is 3.04 for my z-score. So this is equivalent to 3.04. So again, I'm going to use my standard normal table to look up 3.04, and so I'll show you how you do that. All right, so this is just a snapshot of the table. So I have found where 3 is, and I'm going to go across to 0.04 again here. And so where those overlap, which is this 0.9988, that is the area underneath my curve that I'm going to use. All right, so we're back to my normal curve with my shading, but this time remember that the table values always goes to the area to the left, And so actually this red shaded area is actually the area that I'm looking for, which is 0.9988. And so the percentage that my steers are under 1,300 pounds is 99.88%. All right, this is the last question. This time I want to know the percentage of steer weights that are between 1,150 pounds and 1,250 pounds. So I need to change both of these to z-scores. So again, I'm going to take my data value, so 1150 minus 1148 divided by my standard deviation 50. That is equal to 0.04. So that's my first z-score. And so 0.04 is roughly, it's awful close to this. So we're going to just scroll straight down to 0.04. And then I'm going to do my other z-score, 1250 minus 1148, all divided by 50. And so that is equivalent to 2.04. And so I'll go really close to this. That's 2.04. So the area that I'm trying to find is I'm trying to find this area right here in blue. Okay. So what I'm going to do is I'm going to go to my table. And so you look in your table, and this time when you find 0.04 in your table, that is showing 0.5160, which is 51.6%. So what that is representing here, I'll shade that in green here. So that's representing everything to the left of this 0.04 right here. And when I look up 2.04 in my table, that is showing 0.9793. So that's representing everything that's shaded here in the right. Now this is getting kind of messy, but if you think about it for a little bit, if I take the red area and I subtract the green area, then what's left is my blue, which is what I want. So to find my final answer, I'm going to take 0.9793 and I'm going to subtract 0.5160. And so my final answer here is 0.4633, or 46.33% of my steers are between 1,150 and 1,250 pounds.